Although he's over 5,000 miles away from his head office in San Francisco, Bank of America employee Jerry Van Atter has to keep in daily contact. Sending letters is too slow, and because of the 8-hour time difference, phoning from London during their working hours is inconvenient. And the person he wants could be out of the office. The answer for Jerry, as you might expect, is to use his microcomputer. Jerry makes a phone call to his London office and connects his own micro to the phone using an acoustic coupler. He is then linked to the head office computer in San Francisco, which he can use as a kind of mailbox where messages can be left, providing he knows the right password.
Now, I've now told the computer, hopefully properly, that I want to index the messages that are there. And now it'll tell me that I've got 4 messages and who they're from. And I can selectively read any one of them. I can save them on my own disk and print them out here if I want to, store them here for later use, or leave them on the main computer, or erase them.
And not only can he use his micro to read the messages colleagues have left for him from wherever they might be around the world, he can also send his own.
I can send group messages to a bunch of different people, but if I want a message to go to a person, then only that person can read it. The message arrives at the main computer, and it sits there in storage, waiting for the person to read their mail. Having a computer at home means that I'm able to edit messages myself. I don't have to depend upon my secretary to retype things for me 3 times. It also means we can talk to people around the world without having to worry about what the time zone is and whether he's up now or whether he's even in the office. And I know the message is going to get there and not be garbled.
Today we're going to look at how computers can be made to talk to each other, and in particular how they can become a powerful extension to your telephone. But not just for the kind of electronic mail we've just seen. By the way, if you've got a BBC Micro, we'll also be linking our computer here in the studio with yours at home by sending you an end-of-series message as a computer program. We're going to transmit it as a sound, so you might like to get a cassette recorder and a microphone ready to record it at the end of today's program. Well, first of all, let's see how we can link micros together over a short distance, say between a couple of offices. With us again today is John Coll. John, what's the setup here?
Well, Mac, we've got a network of computers here over a very small distance, and all the computers on these benches are connected via a set of cables here. The cables just plug into the back of the computers. Now, they enable the computers to communicate with each other and to communicate, for example, with this unit down here, which is called a file server. And the real purpose and beauty of this system is that all users can then access the disks which plug into the file server here. In addition, all users on the network can connect to the printer and use the printer facilities. They don't have to have one each.
This file server is just, in fact, 2 disk units. Really.
That's right. And if you type catalogue or StarCat on your machine, I do the same, we can both get a catalogue of the disk, even though neither of us actually has our own disk unit. Now, this system can be used over quite a considerable distance, say up to 500 metres or maybe even 1,000 metres.
Yes.
So really quite useful. Well, would you like to load your program, the one called Mac, and I'll load mine. At the same time, John, and they come down. Notice apparently everything working simultaneously, despite the fact that we're connected to the same network. Run the programs?
Obviously quite different programs.
That's right, totally different programs.
And what sort of speed are they transmitting at?
Extremely fast indeed, a lot faster than you can get over a telephone line. A very usable system, really. Now, as well as that, we can actually use it for a certain amount of communication. In fact, if you stop your computer, I can send a message over the thing. I can say, notify Mac, hello, how are you? And then when I press the return key, that message will go down through the network and appear on your machine.
So I suppose we could actually put these out in different offices on different floors or in different classrooms in a schoolroom.
That's right, that's exactly what it's about. It's about sharing the resources within an office situation or within a school situation.
But if you wanted them much further apart, you'd have to go through the telephone network.
That's right. Well, over here we've got a setup using telephones. Telephone network obviously is a worldwide network, so you can actually communicate using the audio tones.
Right, in more or less the same way as we did with the cassettes. And this is a little demo we had which showed how, when we're reading it in from a cassette recorder, you're going to see it more slowly, that the tones are actually fed into the ons and offs into the computer, and of course the computer can do the same sort of thing. And we use that same principle really to transmit programs or data over the telephone.
That's right. In fact, you get the computer to connect to this device, an acoustic coupler, and the acoustic coupler can be used to generate audio tones which go down the telephone. In fact, I can show you a demonstration which illustrates that quite nicely. Wherever you have two users, each having their own telephone system, then it's possible for each of those users to link into their local telephone and transfer stuff across. On this illustration, we've got a program or a piece of text up on the first computer. If we join the two together with an ordinary telephone line, then that text or program can transfer across. In fact, I'll just show you that on this acoustic coupler we've got here. I'm loading a program into the computer which enables the computer keyboard to control the output from the back of the computer and into the acoustic coupler. And if I turn the coupler on, it generates a tone. And if you press some of the keys, you can hear a very short little bleep, and each character is sent out as a very short bleep.
And that's running at about 30 characters a second.
Yes, it is. It's relatively slow, but nonetheless quite usable. Now, in fact, we can use that to communicate exactly as I showed to another computer, and you've got one over there. Can I dial via this telephone, dial you up, and try to talk to your computer?
Well, this time you really are going through the British Telecoms network. You're dialing through to an exchange and it will actually come out here, hopefully if you get the right number.
I'm trying. Have I got the right number?
John, hello. How are you?
Amazing. Let me send you some tones.
Yes, that's good. Excellent.
Right, so now the two computers should be communicating.
That's coming through well.
Amazing. Don't put me off.
Hello, Mike. How are you? And I presume I can send a message back, and by typing it, you'll receive it immediately. I am, surprisingly enough, still great.
A wonderful system, right.
Well, one use of this, of course, would be to transmit programs from one computer to another, but you'd have to be very, very careful because there's no error correction or detection on the line. You could have a lot of errors, and I suppose two deaf people could use it rather than speak on the telephone. They could actually type to each other in a system
indeed.
like this. But actually, for sending messages like that, it'd be crazy because I'd actually have to be there to answer the telephone. If I'm going to answer the telephone, you might as well give them the message anyway.
Yes, it's a real problem. You need something far more sophisticated, an electronic mail system. Now, electronic mail means that you have a large number of computers all over the country or all over the world, and those computers are able to communicate with a large mainframe. Now, supposing I've written a letter and I want to send it to somebody else, I can plug into the mainframe or dial up the mainframe and send that message into the mainframe. And then I might have another message for another person. I can again put that into the mainframe where it's stored. And then I can disconnect and leave the letters sitting there, and then at some stage, several hours later, somebody else could connect on and pick up their message, and then the other person could come on and pick up their message.
This is exactly the same sort of system that Jerry Van Atta was using actually earlier.
That's exactly it.
But there are some publicly available systems like this, and I suppose you could actually send a message to everybody, just broadcast a message and leave it on. When it got onto the system, it would come out with that message.
You can send it to a whole group of people.
Do you actually use them yourself?
Yes, I use it a great deal, as I know you do. I was out in Hong Kong a month or so ago, and I forgot a computer program, and so I had to mail my secretary, send electronic mail to my secretary saying, please put this program on so that I could pull it down. Luckily, my secretary connected to the computer less than an hour later, and I was able to pull that program off in Hong Kong without any trouble.
And did that mistake cost you a lot of money?
No, it's very, very cheap indeed. In fact, it's a lot cheaper than sending letters.
I believe that.
It is.
Well, this ability to send information from computer to computer is being increasingly used in business. Small companies can buy microcomputers and link them via the telephone line to make use of software services held on much, much larger machines. We've been to see one system in action in a rather unusual setting. When you're ill and need something from a chemist, you need it now and not next week, when it might be just too late. Because of this, chemists depend upon their wholesale suppliers to provide a quick and efficient service, often expecting delivery within 2 hours of ordering. With warehouses all over the country, Vestric are a major supplier of pharmaceutical products to chemists and hospitals nationwide. They want to provide a service better than their competitors, and to this end have been developing their mainframe computer systems for around 16 years.
During that period of time, we've converted order entry systems, stock control, management information, and all our accounting into computer systems. So it seemed quite natural that we should then go on and see how we could bring these benefits to our retail pharmacist customers.
What Vestrik have done is to offer an improved ordering system by linking the large memory and processing power of their main computer in Liverpool to a humble microcomputer in the chemist's shop. Programmed specifically to meet the needs of the chemist, orders can now be entered directly into the micro's memory before being relayed to Vestrik by telephone. Pharmacist Barry Harrison was one of the first to order supplies this way.
The system is very, very easy to operate. All my staff were trained within a matter of hours. They find it very, very easy to use. They can enter items when they've got time to do it. It's an alphanumeric code. The first 3 letters relate to the product, and the last digits are a check code. Double ordering is eliminated because if a product is punched into the computer a second time, a warning comes up informing us that it is already on order, and we can then either cancel it or we can repeat that item. It can give me a price, it can check the quantity that they've got in stock, it can tell me exactly what pack sizes are available and how many. And I have all that within seconds of the order being relayed to the wholesale branch.
And to do that, all Barry has to do is to use the phone.
And as soon as I get the clearance code, I then merely press my data button. And on my screen now comes the word transmitting, followed by receiving, showing that the computer centre is receiving that order.
Through Vestrik's link-up of computers, Barry's order is immediately printed out in his local branch warehouse, where it's dealt with in the normal way. By using computers for communication, urgently needed drugs could be on their way to the patient even quicker than before.
I think nearly every retail pharmacy will eventually be placing their order by a computer terminal system. With a terminal in the shop, we cut down the time tremendously. And of course, because we're dealing with dispensed medicines, many of them needed urgently, time is a very important factor in our business.
That was a private service, even though it used the public telephone system. British Telecom runs an information service on large central computers that can be used by anyone with the right kind of hardware and software, and that includes our micro and the equipment John and I were using earlier. Richard Hooper runs this service. Richard, Presto's been around for 3 years or so. How has its usage developed?
Well, I think we've concentrated on what we call rifle shot target marketing. Here, for example, on this screen, you see the index for travel agents. There are about 4,600 travel agents.
And how are they using it?
Well, holiday availability and, for example, booking. They can book airline seats.
So they can book them direct with the airline's computers
Absolutely.
and tour agents?
Through Prestel, through a gateway into airline reservations computers.
But how can a home user use it?
Well, still staying on the subject of travel, which is very popular at home, you've got a service like Sky Guide, which tells you the departure and arrival information at Heathrow Airport. So if you're going out to meet Granny...
Well, let's have a look. She's arriving from the States. Let's look at...
Well, Terminal 3, so that's 17. That actually gives you the status of flights updated a few minutes ago.
It actually is 2 minutes old, is that? How's that done?
Well, the computers that actually drive the arrival and departure boards in the lounges are also driving an American Express computer in Brighton, which is driving the Prestel computers back in London, and there you are.
So you're absolutely certain what you're seeing on your screen is what people are actually seeing in the airport?
Absolutely, just taken off the gate numbers, that's all.
But that's just information. What else can we do?
Well, we use the telephone, so therefore we can send messages back to the computer in a message mode. For example, let me book you some seats at the Barbican Theatre, the Royal Shakespeare Company.
That's extremely kind of you.
220... I made an error. Right, if you look down line 24, 220 232 252, press hash, and this gives you seat availability. What are you interested
So
in?
Henry IV parts 1 and 2, and Poppy. Well, let's try Henry IV part 2. 15th of March, what about
Well,
that?
16th of March is not available. Oh, it's 4-2 you
15th,
want.
yes.
15th of March, £8.50. OK, let's book it for you. This is an electronic booking form, an order form, if you like, which we've called out from the machine. And you'll see that the name of BBC Television Centre, which owns this particular set, coming up, and they're going to actually pay for it.
And the cursor moves along to just where you
The cursor now says we said March 15th.
March 15th.
15, press return. We obviously want
Two
two
tickets.
at 8.50, none at 7, certainly none at 6. We don't want a matinee. Then it says name. Well, let's put in your name, Mac. Press return. Credit card. Well, the BBC's credit card number is 1234. I'm reliably informed. And then you'll see on line 24, key 1 to send, key 2 to cancel. Since this is the last programme they can afford it, I'll send it. Message sent.
It's marvellous. But you wouldn't need a microcomputer to do that. You could do it on a fairly ordinary little dumb terminal like that.
Yes,
What
I
do
mean,
you-
everything we've seen so far, as you say, could be done with that and a colour television set or a black and white set.
What special service have you got to offer for a microcomputer user?
OK, well, here we have the BBC Micro with an acoustic modem, telephone network. It can do everything that we've done already on Prestel. And in addition, there is a service aimed specifically at owners of home computers, small computers in business and schools, and this is called Micronet 800. And what this does, its main feature is that Prestel stores on the computers computer programs which we download called Telesoftware.
So it's not just for the BBC Micro?
It's for
I see
the
lots of
Apple,
other
BBC, Commodore
micros.
PET. And we just store the machines and we can download them to your machine at home or in the office.
And can we do that?
OK, well, let's. I've got a surprise program for you. This is a bit of electronic soft documentation, and if you want to download the program, special function key F5, and we are now actually downloading it. And this is a basic program stored on the Prestel computer.
And how fast is it coming through?
It's coming through at about 1200 bits per second.
And is it error corrected? How do we know we got what's there is actually the program?
There is a checksum at the bottom, and it just checks the number of characters. And if it's OK, it passes the page. If it's not OK, it'll reload it.
And how many programs have you got altogether available to the user?
Oh, there are something like 1,000 programs for different range of machines.
That's amazing. And some of those you have to pay for, of course.
Some of those are free and some of those you have to pay for. This one is free. I'm now downloaded 3.5 frames. I can leave Prestel, pressing F4.
And now comes the real test.
OK, now the real test.
Does it work?
I'm now going to go back into BASIC and now run the program file, press F6, hold your fingers.
I've just been downloaded it from Prestel. Is that all it does? Well, thank you very much, Richard. There are other ways of moving information over large distances other than by the telephone, and you're seeing one of them now. It's television, and computer programmes are already being transmitted by the BBC as part of its teletext service. Graham Clayton is the editor of BBC's teletext service, CFAX. Graham, how does CFAX work?
Well, it's an ingenious way of using the television signal to get pages of information onto the TV screen. The normal television picture is made up of a number of lines, but there are spare lines at the top, and we use these lines to carry CFAX. The flashing dots you see there are in fact CFAX.
A digital signal. Normally you wouldn't see them on an ordinary television.
That's right, it would be off the top of the screen, you wouldn't notice it.
How is that different to a normal television set?
It's got inside it a decoder which takes that stream of data and turns it into pages of information, and there's a hand controller with which you can call up the pages you want.
Well, let's do that now. There it is. Well, how does it link into a computer?
Well, unfortunately, it's not possible to get the teletext signal out of the teletext set and into the micro. So you need a teletext adapter, like this, which is plugged into the micro. The adapter requires an ordinary television aerial. I'll just borrow this one. And this goes into the back of the adapter, like that. Now all I have to do is put the micro into the teletext mode, and it'll begin to receive pages like the one you just saw.
Oh, there it is. So that with this teletext adapter, and of course the BBC Micro, you can convert any ordinary television set into a teletext set.
That's exactly right. You can look at any of the pages of teletext information on any of the TV channels.
So what else can it do for the microcomputer?
Well, we have a page which I think you might find interesting, which I'm going to call up now by dialing 701. You can just see it at the bottom there, and pressing return. And what is happening now is the receiver is waiting for page 701 to be broadcast, going through all the other CFAX pages. And when it comes to 701, there it is, REM. It's the CFAX Telesoftware newsletter.
Which is updated regularly, I
That's
suppose.
right. So if you need to keep in touch with what's happening as far as CFAX Telesoftware is concerned, you can just call up page 701.
OK, so how do we get a program down from the service into the micro?
The first thing to do is to find out what programs are available. So first of all, I'll call up another page, page 700. And the point about Telesoftware on CFAX is that we're constantly changing, constantly renewing the programs. So you need each time to turn to page 700 and find out what is currently available. There'll be a list of programs and a little bit of information about each underneath.
Shall we try and load one down? What about Brickup?
OK, once again, we start by calling up the appropriate page number. In this case, as you can see, 704. And once again, we wait for the sequence to go round to page 704, and then you'll see Telesoftware. Now, I just put this into the Telesoftware mode, and it begins to download the program immediately.
We've got a page there straight away, in fact. But it would take quite a bit of time to load it, so we've already done that. Why don't we load it in from disk and have a look at it?
That's right. Once you've captured a program, you can either run it immediately on your micro, or you can load it onto disk or cassette and save it for whenever you want it. We've got it, as you say, on disk now, so let's just...
Because the nice thing that I like about this program is that it's completely free, and all the new ones will come to you completely free.
That's absolutely right. Once you've bought the add-on adapter, the whole service is free.
Or at least included in your television license.
Absolutely. And you can see how it works. You're asked to guess a word.
Oh, I remember this in a previous program. We saw
Right.
some children using it in
Have a
school.
guess.
Two-wheel vehicle, a bike.
I don't think it's going to like it.
The word was bicycle.
Well,
Oh,
you can't win them all. Try again.
Sorry. Bench.
Much better. And now we get our prize. And eventually, after you've got sufficient words right, you in fact demolish the brick wall and escape at the far end.
And what other sort of programs are you going to be transmitting?
Well, to begin with, we'll be concentrating, I think, mainly on educational programs, though I hope they'll be of general interest too. Some of those programs will be specially commissioned to go with BBC broadcasts. Then we'll be trying things like data files. I hope there'll always be scope for a sort of amateur page, a club page, where people can exchange programs. And who knows, eventually perhaps a CFAX Game of the Week?
Well, thank you very much, Graham, and the best of luck with your Telesoftware service. Well, now we've come to the end of this series of programmes. We hope that whether you've got a machine of your own or not, you've enjoyed the glimpses we've given you of the wide range of things a microcomputer can do. As our final act, and I'm afraid it's only going to work if you've got a BBC microcomputer, we're going to send an end-of-series message from this machine here. So put the microphone of your cassette recorder as close as you can to the television loudspeaker and start recording now. We'll be sending you audible tones, and they last about 30 seconds. To try and make sure the tones are easy to receive, we're sending them at 30 characters a second. So when you come to play the tape into your computer, you'll need to type star tape 3, like this. And here it comes. Well, that music is so beautiful that one day they'll make a disc of it. That's all from us here. The only thing left for me to say is goodbye. Thank you for watching.